Okay, kids, listen up. Today is the day we go find this crazy Bishop Darcy. Today is the day we get him. And we take him and we show him that I run this school. And tell him that he is going to disappear. Okay, so my plan is to go and attack him in his class. So I'm going to go sneak up there again. And then we will go busting into the classroom and we will catch him. Okay, let's go. Come on.
Into our lessons, okay? Yeah, let's go to our math lessons and we'll try.
Hey, you crazy Bishop, yo!
Off the lever! Off the lever! Nine!
Help me, Herr, help me! What will he do? Help me! Herr, help me, please! Come here, you! I will get you!
Ungefär vilken himmel. Där är någon rätt i handen. Där right kommer. Där vill jag se vad vilken himmel.
Good afternoon, good morning to you 7th graders. Today we have lesson 8 and it's Friday, so yes, it's the weekend. Our last math lesson for the week. Today we are learning about linear relations. And before we get into it, let's just describe what linear means. Linear means arranged in or extending along a straight or nearly straight line. And today we're learning about linear relations. So somewhere along our lesson, we're going to learn about a straight or nearly straight line. Let's start reading at the top of page 33. It says a linear relation is a steady, unchanging relationship between two sets of numbers. It's a steady, unchanging relationship between two sets of numbers. For example, a snail traveling at a consistent speed of 2 inches per 1 minute will travel 2 inches in 1 minute, 4 inches in 2 minutes, and 6 inches in 3 minutes. All right? These relationships can be shown in a different way on a table of values. So we could have our table here that we know our snail travels in 1 minute, he travels 2 inches. So now in 2 minutes, he travels 4 inches. And in 3 minutes, he travels 6 minutes. So how far would he travel if we added 4 minutes? Or steady, or just increasing by 2 every time, right? It's a steady, unchanging relationship between two sets of numbers, all right? And if we move on to our next part, we'll come to where we're getting into our straight line. It says from the table, we can get a set of ordered pairs to show the relationship on a coordinate plane. All right, so remember, our set is our numbers for our y value and our x value. So we could have the ordered sets of 1 and 2, 2 and 4, and 3 and 6. All right, so we have these ordered pairs. Now, we can graph these on our coordinate plane. These ordered pairs can be shown as a line of plotted points on a coordinate plane. This is why it is called a linear relationship. All right, so notice what happens when I plot my points on this grid. All right, now notice we started down here at our 0. Now we're going to go over for our 1 minute, and then he traveled 2 inches. So here's our first point. You can see my point right here. And then he goes in 2 minutes, he's going to go 4 inches. So here's our second point. And in 3 minutes, we'll go over 3. He's going to go 6 minutes. All right, so look at our linear line here. We have formed a straight or nearly straight line on our grid. And we can use this to help us answer some questions that we don't actually know from our table. For instance, let's keep reading on page 33, the third paragraph from the bottom. It says you can use the plotted line, which is what we just plotted, to find the values in between the points marked on the line. So we can use this line to find the value of things in between our points that we marked. So if we want to know how far does the snail travel in 1.5 minutes? So right here, here's our 1 minute, here's our 2 minute. So 1.5 is going to be right in between, right? Because 1.5 would be half in between 1 and 2. So follow a straight imaginary line from the halfway between 1 and 2 minutes on the x-axis, which is right here, to where the arrow comes to a line on the grid, all right? So what it means by that is we're going to come up here, and we're going to just use our imaginary line coming up through here. Now, we stop when our line comes across our imaginary line. So now, how far is the snail going to travel in 1.5 minutes? We know we met our line right here, so if we keep reading, we know that the snail travels 3 inches in 1.5 minutes, all right? What about the next one, the last paragraph? It says, how many minutes will it take the snail to go 5 inches? All right, so we're going to follow 5 inches on our y-axis. So here's our y-axis for our inches. So we're just going to follow this 5-inch line, and bam, we meet it right here. So now, let's look where we come at, right about here. We're going to come right down, right in between our 2 minutes and our 3 minutes. So it is going to take our snail how many minutes to go 5 inches? 2.5, right? So that is the benefit of using plotting our points on our grid. We can use our linear line to help us solve questions we don't know. So that is what linear relations are. Linear means arranged in extending along or a straight, arranged in or extending along a straight or nearly straight line. And then we have our table of information, which is our steady relationship between two sets of numbers. A linear relation is a steady, unchanging relationship between two sets of numbers. Now, for your new part, you're going to flip to the next page on page 34, and you guys are going to finish the table of values, plot the points on the graph, and draw the line for the linear relation. So, Sam has a job that pays $8 per hour. So in the hours hours box, you're gonna put 1, and you know he gets $8 per hour, right? And we have 2 more. Oh, that's a really bad one. We have 2 more that we need to fill in. So what's our steady, unchanging relationship? So what about 2 hours? In 1 hour, he got 8. For every hour, he gets $8. So how much is he gonna get in 2 hours? 16, right? Good job. Now, what about if we have 3 hours? So our steady, unchanging relationship. 1 hour, he got 8. 2 hours, he got $16. Now 3 hours, he's gonna get 24. Yep. 24. And now that we finished our graph, we can plot those on our graph, and then we can use that to answer questions 2 and 3. So use your line that you plot to answer questions 2 and 3. And that is all for our new part. Looking over your, we remember we don't have any star problems, so you guys are good to go.